So we've inevitably got to word problems. Word problems are really real-world examples of how you would use algebra. You often have this, when are we ever going to use this? Well, you will actually be using algebra in real life. And the best thing to do is just go through a process of how it's done. So I have here our question. Arthur for short, it's named after one of my oldest friends, Arthur, is 5 years older than Bob. Bob is 12. How old is Arthur? Okay, you might be able to do this without algebra. In fact, I hope you can do this without algebra. It's pretty easy, but it's a good example to go on. Say we had to use algebra to solve it. What would we do? Well, our first step is to use our let statement. Or really statements, I guess. What that means is that we want to find the variables and sort of give them a letter. Okay, well, I'm going to say I'm going to let A be equal to Arthur's age. Pretty self-explanatory reason why. Arthur starts with A, so I'm going to say A. I'm going to say let B be equal to Bob's age. And you want to be really, really careful defining these really carefully. One thing you could add to this is A and B are Arthur and Bob's names now. Often you'll get questions, how old will Arthur be in so many years? But we don't in this case, so I'm just going to leave it like that. But just be really careful. The second thing we want to do is we want to sort of translate English into algebra. What I mean by that is I want to convert these statements here, so I want to extract as much information as possible that they give us. So when you go to get your teeth pulled, it's called an extraction. So if you imagine that the dentist goes into your mouth and extracts your teeth, just imagine you go into this syntax here, these sentences, and extract little nuggets of information, and we want to turn that into equations. And the third thing we want to do is we want to use the algebra that we know to solve. We want to say, okay, this is no longer a question of age or geometry or chemistry or physics. This is now an algebra question. Let's do it with this one here. So I'm going to say let A be Arthur's age, B be Bob's age. Okay, so it says Arthur is 5 years older than Bob. So I just want to take this first bit. Arthur is 5 years older than Bob. Okay, two ways we could write that. Arthur's age now is equal to Bob's age if we added 5 years to it. So just run that through in your head. This first sentence here is exactly the same as this one. This is a 5, not an S. Another way we could say it, if we took Arthur's age and we took 5 years away from Arthur's age, it would be the same age as Bob. These are equivalent statements. Okay, so run in your head, the top one here, Arthur's age now is the same as Bob in 5 years. And this one, the bottom one here, if we took Arthur's age and we took 5 years away from that, that would be Bob's age now. Okay. The second one is really easy. Bob is 12. Well, if we wanted to convert that into an algebraic expression, B is 12. And the third one, how old is Arthur now? Well, we want to find what A is. A equals, we don't know. How are we going to do that? Well, we're just going to substitute. Wherever we have a B, we're going to put it there. So, Arthur is Bob's age, and Bob is 12. Plus 5, I've just taken this first equation here and put it down there, and I know now that Arthur must be 17. Well, let's check it out. If we took Arthur's age, which is 17, if Arthur was 17 now, 17 minus 5 is 12, and this says it's 12, so yeah, we've got the right answer. It's a really, really simple example, but it is essentially all that word problems are. So just to go through it, I made a let statement, so I gave all of our variables letters, and when we have things in letters we can use the power of algebra to solve them. I translated that from English. Arthur is 5 years older than Bob. Bob is 12. How old is Arthur? Then I used the power of algebra to find out that Arthur must be 15 if Bob is 12.